Welcome back, Calculus. We're going to start 7.1. It's the second fundamental theorem of calculus, and it actually makes the most sense if you sort of jump into the problem. If we have a function defined as capital F of x equals the integral from, now this can be any constant or just one of these is x, is our independent variable, and then f of t dt. So it makes sense to have two different variables, or you can just stick with me for a second. So let's define f of t as this. So if I asked you for f of x, which is the directions, what they want you to do is the integral from 1 to x of that function for t minus t squared dt. So what is capital F defined as? Well, you would do the antiderivative of that. So add 1 to your exponent and divide by your new exponent. 4 divided by 2 is 2. And hopefully we've done enough of these where this makes perfect sense. 1/3 t cubed from 1 to x. And so when I plug in those values, I like to rewrite. You don't have to. That capital F of x is equal to 2x squared. Remember, we plug in minus 1/3 x cubed. And then we have to plug in 1 and subtract those values. Just make sure that you're doing the quantity. Well, 1 squared is 1 times 2 is 2, which is the same thing as 6/3. And the reason why I'm doing that is because I want to do 6/3 minus 1/3, which would give me 5/3. Hopefully all of what I just said makes sense. But that's not really the point I'm trying to get at in this lesson. The point I'm trying to get at is what's the derivative of that? Well, the derivative of that, you'd bring the 2 in front. Well, 2 times 2 is 4. X to the first power. Don't have to write that. And then bring that 3 in front. 3 times 1/3 is 1. X squared. And then the derivative of a constant is 0. So the whole premise of this, I bet this is obvious right now, that the derivative is equal to the original problem, except we replace the t's with x's. And I can do the same thing with the second equation. And I hope it makes perfect sense. That capital F of x would equal the integral from 1 to x of cosine of t dt. So if I asked you to do that, well, cosine antiderivative would be sine, because remember the derivative of sine is cosine of t from 1 to x. So then, you know me, I'm going to rewrite f of x. We have sine of x minus sine of 1. Now, I don't know what sine of 1 is, but I know that this value is always a constant, which is important for when I go to the derivative of that. Well, the derivative of sine is cosine, and the derivative of a constant is 0. Well, there's no reason to write minus 0, and what do you notice? That's the same as this. So we're getting close to the second fundamental theorem of calculus. The reason why we're not quite there yet is what if this exponent is slightly different? Let's see what happens. Well, if I did the same steps and I found out that f of x is equal to the integral of from 1 to x squared of t cubed dt, well then the antiderivative of that would be 1/4 t to the 4th power from 1 to 4. And then if I plug in those values, well, 4 to the 4th, I don't know what that is, but one of the 4's will cancel. Oh, whoops. What was I doing? I don't know what's wrong with me. 1/4 t to the 4th from 1 to x squared. Sorry if you were super confused. So as I plug in, that would be 1/4 x squared to the 4th. Remember, you multiply your exponents there. 2 times 4 would give me 8. And then plug in 1. Well, 1 to any power is still 1. We have that 1/4. Now, let's take the derivative of that. Well, the derivative of that is bringing the 8 in front. Well, 1/4 of 8 would be 2, and it becomes x to the 7th power. and the derivative of this is 0. Well, that does not match what we have up here. Well, let's actually do this a little bit longer. Like, instead of rewriting capital F of x as that, let me just write it right here. What if we rewrote it as 1/4 of x squared to the 4th? Okay, stick with me because I'm almost there. Well, now if I did the derivative of that, we'd bring that 4 in front. We would leave x squared alone to the 3rd power times the derivative of the inside, which would be 2x. Okay, well, it still doesn't quite look like this, but at least you can see the something being cubed piece. So I kind of want to just tell you what the rule is. So if I went back to this problem, and I asked you for the derivative of x from all the way up here, the main premise is that you can replace x squared in for t, x squared in for t cubed. But because of that this is a function in and of itself, we have to do the quotient rule. I'm struggling today. I'm sorry, that's not the quotient rule. That is the chain rule, which would say then you have to take the derivative of the inside. Well, what is the derivative of the inside? Well, the inside being x squared would be times 2x. And now when I simplify that, you know, x squared cubed is x to the 6th times 2x would give you 2x to the 7th, which now matches this answer. So before I move on to the 4th problem, let me point out that you didn't have to do that from here to here. Notice that all I had to do is plug in my x's in for t's, and that's because the derivative of x is just 1. So if I were to take this problem and multiply by 1, it doesn't change the value of anything. Same thing with this. If I wanted to go straight from f to this problem, I can just plug x in for t, because remember, the derivative and the antiderivative will cancel each other out. And if you applied the chain rule, if I say it correctly, the derivative of x is 1. Well, multiplying by 1 is not going to change the value of that. So maybe you want to make a conjecture on what will happen when I ask you to find, and you might want to rewrite this problem as 6t to the 1/2 power. If I were to ask you to quickly go from f of x to f prime of x, I'll try and squeeze it right here. And remember, the definition of f of x is the integral from 1 to x squared of lowercase f of t. So what will happen is, for the derivative, it will become 6. X squared will replace the t, still to the 1/2 power, but then you have to multiply by the derivative of the inside by the chain rule, which would be 2x. So when I simplify that, what you'll see is the actual answer is, well, x squared to the 1/2 will be x to the 1st times this x, so it would be x squared, and 6 times 2 will give me 12. Well, let's see if that actually works out that way. So if I did the antiderivative of that, I would add 1 to the exponent, multiply by the reciprocal. Well, 6 times 2 is 12 divided by 3 would give me 4, from 1 to x squared. So if I plug in those values, I would have 4x squared to the 3/2 minus, well, 4 times 1 to any power is still 1, so it would be minus 4. Well, if you look at my rule then, you bring for the derivative, you bring the 3/2 in front. 4 times 3 is 12, divided by 2 is 6. It's now to the 1/2 power, and then times the derivative of the inside is times 2x. Or you could simplify this, and then the direct derivative would give you that. So a bit busy, but the second fundamental theorem of calculus, I'm going to go to the answer key, is basically the chain rule. So if you have a function defined as, and they use capital F, lowercase f here, and it's from any constant to some function, okay, the example we did earlier was x squared, you replace that function in for t, so it's still f of g of x, because you're replacing t with that, and then times the derivative of g of x. Okay, and we can do the same thing. We could actually do the same thing if the function's here. The only thing is you have to think smartly about what would happen, is because if you did the derivative, it would be some constant minus this function. So what you'd have to do is think about how it's negating, so it would be a negative. But I believe they rarely ask that question. This is just a different way of asking you the chain rule. Now the way I've printed this, it's not actually from page 588, at least I don't believe it is. It might have accidentally changed the page number there. But what the answer key is doing is summarizing all of these. So feel free to pause the video and write down anything you want. But I feel confident that I've explained this, although I accidentally called it the quotient rule and I made some other typo in here. But you can see he explains it really well with the answer key, that you just plug in the x's in here, and then the derivative of x is 1. So it makes perfect sense that the derivative of f, capital F, is the same thing as replacing t's with those x's. Same thing with this problem. The derivative of capital F, the antiderivative and the derivative cancel, and you just replace the t with the x times the derivative of x, which is 1. You can do the same thing on the next two. I believe I did a decent enough job of explaining the steps that you will eventually be able to do this rather fluidly. So pause the video, write down what you need to. These are your notes, so whatever you need to be successful. I'm going to end the video, and I will see you in the second video explaining the rest of these notes.